Hello everyone, welcome to sqadia.com. We are still talking about the pituitary, pineal and adrenal glands, and this time at this point in time we'll talk about the second part of the pituitary gland, that is the neurohypophysis. We've already talked about the first part, that is the adenohypophysis, and now we'll take a look at what the neurohypophysis is. This section has been divided into an overview of the neurohypophysis, which will explain what this part is all about. Then we'll see the clinical correlations of what happens if the development of the pituitary gland does not go as planned. Finally, we'll talk about some pituitary adenomas in the end. So, starting off with the neurohypophysis, it develops from an evagination of the neuroectoderm of hypothalamus or the floor of the third ventricle. So we talked about it in the beginning of this presentation that the development of hypophysis cerebri or the hypophysis cerebri takes place from two sources, one of them being the neuroectoderm, the other being the ectoderm of the mouth, the primitive stomodium. So the neurohypophysis in itself, it develops from the neuroectoderm. And where does this neuroectoderm comes from? It lies in the developing hypothalamus or the floor of the third ventricle. In the figure you can see this is the area from where the development of the neurohypophysis takes place. The development of neurohypophysis is shown in yellow. So it differentiates into two parts. The two parts of the neurohypophysis, the pars posterior, which is known as the posterior lobe of the pituitary, also known as pars nervosa. And finally, we have the stalk of the hypophysis. This is the stalk of the hypophysis, which is also known as the infundibulum. So the development starts from as an evagination of the neuroectoderm of the hypothalamus. It divides into two parts. The first part being the pars posterior, which is the posterior lobe or pars nervosa, and finally we have stalk or infundibulum of the hypophysis. So now, the neuroectodermal diverticulum from the floor of the third ventricle and ectodermal pouch from the roof of the stomodium fuse with each other. Now now we're talking about the fusion of the neuro and the adenohypophysis. So here in the figure you can see this in blue is the adenohypophysis and this in yellow is the neurohypophysis. So adenohypophysis originates from the ectodermal lining of the primitive stomodium. The neurohypophysis, on the other hand, it arises from the neuroectoderm of the developing hypothalamus. Now, both of these tend to grow towards each other and they kind of fuse with each other. However, there remains a cleft in between, and this cleft can be seen in the adult pituitary as well. This is the cleft I'm talking about in white. So eventually the neurohypophysis and adenohypophysis, they fuse with each other with the cleft in between, and the fusion causes leads to the development of the adult pituitary. Now let's talk about the clinical correlates as to what happens when the development of the pituitary does not go as planned. So we have craniopharyngiomas. So what are craniopharyngiomas? The Rathke's pouch is detached from the primitive oral cavity to form adenohypophysis. We talked about this before. Rathke's pouch is actually the evagination that is formed from the ectoderm of the developing stomodium. So when as the development proceeds, this Rathke pouch is cut off from the developing stomodium. Now, the original site of attachment of this pouch, it comes to lie in the roof of the primitive oral cavity. It comes to lie in the roof of the primitive oral cavity and in the region of the roof of the nasopharynx. So in this region somewhere, this communication between the primitive stomodium, it comes to lie, and the Rathke's pouch. Now the tract of the Rathke's pouch, it forms a craniopharyngeal canal, and the craniopharyngiomas are actually tumors that can lie in this canal or in the roof of the nasopharynx. So this is a craniopharyngioma shown in the figure, which lies in the roof of the nasopharynx. This is actually a tumor of the rat case pouch or the craniopharyngeal canal. So pituitary, let's talk about pituitary adenomas. So there are three types of pituitary adenomas which depend upon the type of cell that is involved. So we have chromophobe adenomas. Chromophobe adenomas, they actually they affect women more as compared to men, and women between 20 and 50 years of age. They usually present as headache and bitemporal hemianopia. So hemianopia is half vision or absence of half vision. So in chromophobe adenoma, there's headache in the patient and there is loss of vision on the temporal side. So this is the temporal side towards the temple. So there's loss of vision, bitemporal loss of vision on both the temporal sides, and this is known as the bitemporal hemianopia. So moving on, we have acidophil and adenoma. Acidophil adenoma, it gives rise to gigantism in children and acromegaly in adults. So it causes an increase in growth hormone production, as a result of which there's gigantism in children when the bone plates or the maturation plates have not yet been matured, and there's increase in the size of bones, or acromegaly in adults when the bone plates have, or the epiphyseal plates have fused with each other, and there's just largening or thickening of the bone tables themselves. And finally, we have basophilic adenoma. The basophilic adenoma causes accumulation of fat on face, neck, and trunk, leading to Cushing syndrome or Cushing syndrome-like features. So this was all about this section. In this section, we talked about the neurohypophysis, that is how the neurohypophysis developed. Then we talked about the development of the adult pituitary and the fusion of the adenohypophysis and the neurohypophysis. And finally, we talked about the clinical correlates of the clinical correlates, which included various conditions that occur when the developmental process goes wrong. I hope you understood it and found it interesting. For further such sections, keep watching sqadia.com.